Hi everyone, my name is Patrick Violet, and I am with the Issaquah Robotics Society. And I just wanted to put together this video as the first in a series of videos to try to teach people how to program, kind of what programming is. Okay, so to start out with, this is going to be talking about Java and programming in general. So let's get started. Alright, so the first question is, what is a program anyway? Okay, I don't know about you guys, but I went to see a pretty awesome play last Friday. And they passed out programs there, which is kind of interesting to think about, because a program, is just a plain series of future events, items, or performances. And so in the case of the play, it is like what's going to happen that night. In the case of a computer program, it's going to be what the computer is going to do. It's going to be instructions for the computer to follow. Okay. So computers need programs in order to work. Okay? Computers are highly precise machines, but they also need precise instructions. So when we talk to computers, when we write computer programs, computers will do exactly as we tell them to. No more, no less. They follow precise instructions because they're precise machines, which means they're useful but also annoying at times. So you'll learn to love them. Okay? So the question is, how can we computer whisper, or how do we actually program a computer? Because computers think in zeros and ones. And it would be pretty darn tedious to type out everything we wanted the computer to do in zeros and ones at the machine core level. So what we've got here is actually we have computer programming languages. That's how we communicate. And just for kind of a point of reference, I'm trying to make the vocabulary words in green. So I don't know if you're taking notes or something. Anyways, so there's that. So programming languages are how we communicate with computers, which think in ones and zeros, and we think in other languages. Okay? The most basic languages are called low-level languages. And they more or less deal directly with the computer in those ones and zeros. They map onto what's called machine code, which is just code that the computer machine, can run. Now, again, tedious, right? So what computer scientists and many other people have done is come up with something called a high-level language, which provides programmers with abstractions to better communicate ideas. And so generally they can read something like English, or at least Spanish, if you don't really understand the programming language that you're looking at. And so high-level languages can communicate higher-level ideas. So instead of saying 0100001, I can say print out a value, or store something in a variable. And we'll learn what those things mean later on. But that's just kind of a high-level idea, high-level of high-level languages. Okay. So now specifically, okay, so high-level languages. Now, we said that high-level languages are written in something like English, but computers think in zeros and ones. So somehow, high-level languages, high-level code has to move into something called machine code. It has to be understandable for the computer. And so, for most high-level languages, there's something called a compiler that is going to convert a high-level code that we write in English into machine code that the computer can understand. So you can kind of think of it like an interpreter, and if you're in a foreign country, like it's kind of the idea behind a compiler. So high-level code and high-level languages are useful for human programmers because you don't have to think in zeros and ones. And a compiler is a program that converts high-level code into machine code. Okay, kind of straightforward. Okay. So now, kind of the big question. Java. What's Java? It's a programming language that we use in the Issaquah Robotics Society. Okay? And basically what happened is Java came out in the late 90s and solved some issues of C-based languages. And if you don't know, C is one of the first computer programming languages that came out. Okay? So it has some issues. Now, here's the thing. Okay, you write code in source code. Okay, you write your code. And in order for the computer to run, it has to do what? Well, it has to compile it, right? Because our high-level code up here is going to be in English, but computers need machine code, so you've got the compiler in between, right? Okay. So what's going to happen is you can think about this kind of like puzzle pieces, okay? Our code, this specific piece of code, is written in such a way that it fits in with this computer pretty well. So it's kind of integrated into the computer's platform and other computers like it. But then the question is, what kind of happens when you move to another computer over here, where the fit may not be quite as good? Well, you'd have to have your own compiler over here and recompile all of this code that we've written, recompile it into machine code of another kind for this other computer. So that's kind of a problem because it's kind of a hassle and you can't just run things like you might want to. You have to recompile them before you do. So Java actually solved that problem with something called a virtual machine. So let's say we have all these different platforms or things that are going to run our code. We've got your computer, right? Pretty nice green little squiggly thing. We've got a TV and we've got the toilet. Because one of the big things that came out with Java was that it was going to run everywhere because the code was so portable. So in fact, yes, toilet possibly could run Java. Anyway, okay, so we've got all our code, right? And it looks the same way here, but it needs to fit in with the computer, which looks kind of like this. It needs to fit in with the TV, which looks kind of like this. And it needs to fit into the toilet, which looks kind of like that. Alright, so what's the solution? Well, you create something called a virtual machine. Okay? The virtual machine is going to kind of simulate that machine code. Okay, so we're going to have Java code up here compile into something called bytecode. Java Virtual Machine, JVM, bytecode. That will in turn run on the computer. So what we've done is we've put this middleman here. And what happens is, yes, you will need a different JVM for each different platform you have. But if I've compiled the code into bytecode, I can run it immediately after moving it from place to place. There's no need to recompile because, look, it's the same sort of interface here. No matter what it looks like, the bottom part, the connecting to the computer, looks kind of like ET sideways. Maybe someone giving you the bird, or maybe like the United States or something. Okay? So the point is that you now have portable code that you can take almost anywhere. And that'll happen in something called jar files, and that'll be an exercise for you guys to do later, is figure out what a jar file is. Okay, so other benefits of Java, just kind of bulletproof. It's got something called strongly typed and statically compiled. So for beginners, this is good because it'll catch a lot of your errors at compile time before you actually run your code, not at runtime. Because what happens is, before you can run something, right, you have to compile it into machine code that the computer can understand, and then you can actually run it. And it'll catch a lot of errors before you ever run it, so you won't break things, which is kind of nice. Okay. Then there's also righteous APIs, right? So Java's been around for a while, and it's a big deal, and there are many libraries to do complex things, whether that is input and output, right? So like reading from a file, reading from the keyboard, or displaying text, or even making graphical user interfaces like GUIs. There's something called Swing. There's a bunch of threading for running multiple threads, running or in other words, programs that are running like multiple through multiple streams at once. There's even like music libraries. Java has a lot of APIs or application interfaces. Okay. And then the final thing is that Java is an object-oriented language. And we'll talk about what that means a little bit more later. But basically, it just allows for modeling of the real world. What object-oriented programming says is that things can be modeled with information and behavior, and basically everything around us is just an object that interacts with other objects. And so object-oriented programming allows for a more accurate representation of the world rather than just a laundry list of code that runs down. It allows for objects to interact, and that allows you to create some pretty powerful things. So that is about all the time we have today in this segment. So thank you for listening, and here are some exercises that would be good for you to do. So these are just kind of figuring out what languages are, kind of what high-level languages are, So pause it, read these, do them, or not. But anyways, thank you for listening, and I'll see you next time.